The Essential Education projector range from Hitachi sponsors ICT programs.
Coming up in today's programme, a science teacher swaps her bucket and spade for a personal digital assistant, a PDA, on a trip to the beach. We visit a Year 8 class making animations using webcams. And we've got more top tips.
My top tip for ICT, when you want to talk to the kids, get them to turn the monitors off. That way you get their full attention.
Hello and welcome to the programme. We start today with biology. Anthea Cliff's usual experience of using ICT is a trip to the computer suite. But she wants to make her Year 7's next field trip, collecting data from rock pools, a bit more high-tech. So what can she do?
What I really need is something that we can take down to the beach that's portable, that they're not going to break easily, where we can actually collect data to do with the temperature of the water and the oxygen levels.
Paul Preece is a leading practitioner of ICT in science. He's going to show Anthea how to use PDAs on her trip to the beach.
A PDA is a really fantastic piece of kit because they allow you to go out and experience real science outside of the classroom. They give you immediate feedback because they produce graphs for you, generate them automatically, so you're not focused on the obtaining data, you're focused on the analysis of data. So that it allows them to adapt and change their experiment as they are going along and makes them become more interested in exploring what they do. Right, well, I mean, the ones that we have available here, we have a temperature sensor and an oxygen sensor. These are very portable, so the idea is these students can take these down to the beach. So what we could do is we could start measuring from where the rock starts, place the measuring tape down the beach, and every so many metres we could ask them to go along to the nearest rock pool and actually measure the temperature and the oxygen. So now we've talked about how we're going to do this, I'll explain a little bit more about how we use the PDAs. On the screen here, I'll just take the pen out, we have a digital readout that immediately gives you a feedback as to what the temperature is. Obviously, if you're measuring rock pools, this is preferential to using a thermometer because with a thermometer you have to make sure that you're down eye level and so on, whereas this one is quite remote, easy to do and very easy to dip into where you want to dip it.
Next, Paul shows Anthea the sensor which measures the amount of saturated oxygen. The process is simple. The sensor just needs to be dipped into the water to get a reading.
So once we've got all this data recorded, what do we do with it then?
Right, so what we've got here, we've got an Excel package. I produced this worksheet which is directly related to this one on here. On this programme, the students will need to enter all the data that they have.
The spreadsheet which Paul has compiled has fields for inputting the distance down the beach, the number of different plants and animals, the temperature and saturated oxygen levels. The software will automatically generate graphs so that patterns are easily identified.
This will be a really useful opportunity for the students to be able to use something as portable as this, and especially to be able to collect the percentages of oxygen, which we haven't been able to do before.
Right, what you're going to do in your groups, in twos, you're going to put together these data loggers that we've got here. This is the PDA part. You then have to slot in the flash logger.
Anthea takes the class through the equipment, including how to set up the oxygen sensor with an electrolyte solution.
Any questions at all? Yes.
How will we know the true temperature of the rock pool?
The true temperature. What do you mean by that?
Well, how long do I have to hold the probe in the rock pool for?
Good question. It's not actually like a thermometer where you have to wait for it to stabilise. With these ones it's pretty instantaneous and you'll see it'll come to a cut-off temperature fairly rapidly within a few seconds. Okay, any other questions? Okay, we're ready?
Pupils begin by marking out intervals along the beach for their data collection points.
Is that 20 metres there? Okay, right, if you just drop that down, that's lovely.
They use the PDAs and sensors to measure the water temperature and oxygen saturation levels.
Let's see what we got in here. We have green and brown seaweed and what are these again?
Mussels, yeah, and that weird thing there.
And limpets.
Yeah, that's it.
It's very clear, isn't it? 125% oxygen. How deep is it?
51 centimetres.
We're 40 metres in and now we're going to record the temperature.
It's 19 Celsius.
All the data the pupils collect is recorded onto printed versions of the spreadsheet which Paul showed Anthea when they first met.
Do you want to write something down?
Red coral weed. That pink stuff there's sponge around the side. I found some sea snails.
We're going to take back our clipboards to school and look at the data that we've collected back there.
The class returned to school and input their data into the spreadsheet.
We want to see what this looks like in terms of a graph and see if we can notice any trends.
The further away from the beach, the less oxygen. Yeah. That one's going down steadily, isn't it?
Yeah, that's because when the tide, that's underwater more often, so it doesn't get as much oxygen.
And if they're in secluded parts like little rock pools, then they won't get as much.
Okay, how can we account for this level here?
We could say if there's a lot of animals in that part of the water, then they'll be using a lot more oxygen than in these parts here.
The temperature goes, more species are high at about 15.
Yeah.
There's more. But most
They
of
don't
it,
like cold temperatures.
no.
We should plot the depth against the temperature so we can see that our theory is right about the smallest water being the heatest and the biggest water being the coldest.
What we're going to try and do is to have feedback from you, what you've found, what you think you've discovered from doing our activity today.
What I've got is the higher the temperature is more like consistency of plants and animals, and the plants that when they had like a high amount of animals there was a high amount of plants as well, so I think they work together. And the sort of what I thought the hotter the water was going to be, there'd be less animals and plants, but there was more.
We were imagining that if we had warm pools that possibly there'd be fewer species in there, but a lot of the evidence isn't showing that. You've worked really hard there, haven't you?
At the end of the lesson, what do Anthea and Paul think that ICT added to the experiment?
Because they were able to get immediate answers about the amount of oxygen levels in the water, and they were able to design and change and adapt their experiment as they were going along, and that was really valuable.
The use of ICT was a great resource for our students to be able to use because they had instant feedback, and it showed them the portability of ICT as opposed to just being stuck in a lab somewhere or stuck in an ICT room. They're actually able to use it in the field, and how tremendous was that? Really great.
This really practical application of ICT in the field could be applied to many other scenarios, from pond dipping to assessing pollution levels in towns and cities. Don't forget, you can find out more information about the resources that Paul and Anthea used by visiting the Teachers TV website. And now some more top tips.
A collection of 10 digital cameras would allow a class of 30 to have one between 3. The students really enjoy taking the camera and using the photographs. This digital camera costs less than £20.
It's okay if the pupils know more about ICT than you. In fact, that's to be expected. It's better to simply set an objective and allow the pupils to creatively find solutions for themselves using their natural ICT skills.
The digital recording facility on a computer is underused. It's really easy to switch on your digital recorder. All you need is a microphone. You can record yourself or what children are saying. It's very easy for the children to then play it and listen to themselves or to you, so that not everything has to be written on a computer. Use the digital sound recording.
Finally today, animation. Nikki Prince wanted her Year 8 pupils to make some short films as part of their Media Studies course, but without using a Hollywood budget. Here's what she did. Creating animations like these can be a slow, time-consuming process, which can make it difficult to fit into the school timetable. But there are ways ICT can help. Using some simple equipment, these Year 8 pupils at Coombshead College in Newton Abbot are going to produce their own animations in just 1 hour-long lesson.
We're using a relatively cheap webcam, about £35, clamped in a piece of scientific equipment that we've borrowed from the science department. It means we can afford to have more than one in the classroom, which means the students can work much more quickly. So within one lesson, almost, all students can make an animated sequence.
The pupils have already storyboarded a sequence they want to animate based on the theme of a journey. They begin the lesson by collecting all the materials they'll need. Some have drawn their own, others are using pictures from magazines or the internet. After cutting out the bits and pieces they need for their animation, they work in pairs to capture the individual frames.
Captured.
While one pupil lines up the materials under the webcam, another captures the image on the PC using Monkey Jam, one of a number of free animation software packages you can download from the internet.
Capture. Captured. Captured. Start bringing them down towards the big part. Captured. Yeah.
The advantage of doing animation is it is very immediate, it is focused, it encourages students to work together, to collaborate, and they are working as artists and using the ICT naturally to support their artwork.
Start bringing the harps in now, roundabout now. Oh no. No, he's touching it. It's a bit like... No, because... Right, no. It's a bit odd because it's sort of like... Take the cave away. When they get off the page, then bring it in.
After just a few minutes capturing frames under the webcams, the pupils have built up enough images to create a basic animation. The software then allows them to play back what they've done, giving them the chance to review and edit their work.
Is a hand?
Yeah.
Do you reckon we should have put the that in a bit more?
Yeah.
It's really simple technology. It's accessible. Students understand how to use it very quickly. They can actually make a film within a very short space of time, but it does encourage them to hone their thinking skills and to collaborate with one another.
Well, it's basically like a guy in his expensive car. He goes out on the motorway for a drive and he gets stuck behind this really slow pickup truck who's really annoying him. And in the end, he gets so annoyed and he doesn't bother braking to swerve out the way and he just crashes into the front, lands in the back, explodes.
Yeah. When you get to, like, when you know how to, and you've had a lot of practice, then it's easier.
At the end of the lesson, the animations are saved onto the school network, which means they can then be instantly shown on the interactive whiteboard, allowing the groups to critique each other's work.
Lillian, give me an example of how those two animated sequences you've just seen are different from one another.
One of them used paper as the main characters and the other one actually used proper pictures.
So they used photos as part of the story.
I like the way on the fishy one, it was just smooth and it looked like it was a real animation.
It looked quite professional, so you liked that look. By asking focus questions, it will encourage them to be critical about their work, but also enable them to comment about what they would do in order to improve it, which is the important part of the process. And finally, moving image is a prized product and they see their own work in front of them.
That obviously captured the pupils' imaginations and produced some excellent results. Don't forget, you can find out information about anything you've seen in today's programme, or indeed the series, by visiting the Teachers TV website. And I'll see you next time.
Essential education projectors from Hitachi sponsor ICT programmes.